Hi all, I'm Dr. Sujya, Assistant Professor in the Department of Computer Application at Dr. S.N.S. Rajalakshmi College of Arts and Science. Today the presentation I'm going to talk us about a combinational logic circuit. So before going into combinational logic circuits, let's discuss about what is a logic gate. So logic gate are the OR, AND, NOT, NOR and etc. So called as a logic gate, and this logic gates have been combined together to form a combinational logic gates, and this has been designed. So first we are going to see is about the half adder. Half adder is a combinational logic circuit which consists of two gates, that is AND gate and one XOR gate. So in a half adder it consists of two input terminal, for example it is A and B, and these being added together which generates an output. The output is carry and sum, and these two outputs are basically called as carry and sum, and this is the logical expressions of the half adder, where sum is calculated by A XOR of B and carry is calculated by A into B. So this is of half adder, and in this circuit diagram it is being represented that an XOR gate is being added as taken, and an AND gate is taken, and the input A and B is being given into the XOR gate, which produces an output of sum, and this A and B is being given a carry, which produces a carry of A into B. So the truth table, we have taken an inputs of 0 zeros, 0 and 1, and 1 0 and 1 and 1. So finally it produces sum and carry as an output. So this is the truth table which we have discussed in the previous slide. And next we are going to see is about the full adder. So full adder is totally different from half adder. Here, as in the previous half adder, we have taken two gates, that is XOR gate and AND gate. But in case of a full adder, we take two AND gates, two XOR gates, and one OR gate. And this full adder adds these three binary digits, and among these three, one is a carry and we obtain from the previous addition as seen, and then the two inputs A and B is being taken, which designates an input with a carry C out and a normal output sum. So what is discussed here is we have taken three inputs, that is A, B and C, and this get processed and finally we get an output of sum and carry. Here, what is the speciality of this full adder is, in a half adder, the output which we get is not taken again as an input to another circuit, but in case of a full adder, the output what we get from one logic gate is being taken as an input in another logic gate, and that output is taken again as an input in another logic gate. So it has been clearly shown in the following diagram, where first XOR gate is taken and A and B input is being passed on to the XOR gate, where we get a result, and that result is given to input to another gate, and another Cin is being introduced. Cin is input, the third input, which is being given as an input, and finally we get the sum. And finally the output which we got is from the first XOR circuit is taken again as an input to an AND gate, and finally it produces A XOR of B, and these all gates output is being taken as an input to one OR gate, which finally produces a result of carry. So this is the diagram which we have discussed in the previous slide. This is the truth table. Here we have taken three inputs A, B and C. So the values what we have taken here is 0, the binary value of 1, the binary value of 11, the binary value of 5, the binary value of 7, the binary value of 9, the binary value of 8, and the binary value of 10. So here when these A, B, C get passes on with the XOR gate, AND gate, and that is 2 XOR gate, 2 AND gate and 1 OR gate, it produces a result of sum and carry. So for the combinations of zeros, we get the sum as 0 and the carry as 0. But in case of triple 1, we get the sum as 1 and the carry as 1. And when A is 0 and the other twos are 1, we get the sum as 0 and the carry as 1. And when we take input of 1 for A and B for 0 and C for 1, we get the sum and carry as 0 and 1. So vice versa, it differs on the triggering of the values of the sum. So now we are going to discuss is about what is the difference between these half adder and full adder is. The half adder is a type of combinational logic circuit that adds two of the binary digit, where in the full adder it is also a type of a combinational logic that adds three binary values for performing an addition operation which produces a sum and carry value. But in case of a hardware architecture, here we consist of AND gate and XOR gate. But in case of full adder, we take two XOR gate, two AND gate, and one OR gate. And the total inputs here we take for a half adder is A and B. And the total inputs we take for a full adder is A, B, and C. And the usage we consider here is we use for digital measuring devices. But in case of full adder, it has been used for additions of multiple bits. So this is the logical expressions of half adder and full adder, which is detailedly expressed in the previous slide. Thank you.